Blender provides a lot of information with its interface, and can be flexible enough to fit the workflow you need. Let's go over some of the basics on how to interpret and interact with Blender's UI. Before we begin, I want to point out that there is a very handy display at the very bottom of the user interface. This is an informative display that lets you know what each click can do in the context your cursor is at the moment. It also applies to when certain hotkeys are being held down to change the function of certain clicks. For example, if you hold Shift, you can see the information at the bottom changing. It tells us that without holding Shift, your middle mouse button rotates your perspective, but holding Shift pans your perspective. Feel free to refer to this display at any time while watching this series or playing around with Blender to learn more of its features. As a quick reference, here are what some of the mouse icons translate to. Now, the next big thing you'll notice is that each important section of the UI is separated into panels. These panels are scalable if you click and drag any of the boundaries, and they can also be whatever you'd like them to be. Simply click the drop-down menu in the top left or bottom left of a panel and select a different type of editor. You can also create more panels by right-clicking a boundary, clicking Split Area, and then left-clicking at a position of the screen you desire. To delete a panel, simply right-click a boundary, click Join Area, and left-click over the panel you'd like to overwrite. Additionally, if you would ever like to maximize a panel to focus on it, simply mouse over an area and press Ctrl Space. You can also press Ctrl Space again to return. While this is extremely powerful, Blender also provides default workspaces you can choose from that set up the appropriate editors for specific workflows. You can find these workspace options in the tabs above. For hotkey users, you can press Control Page Up or Control Page Down. We will be going over each of these workspaces in future videos. However, for this video, we will focus on the primary editors of the Layout workspace. Further introduction of other editors will be given in editor-specific videos. So, let's begin. If you saw our viewport navigation video, then you already know what the viewport is. This is where our 3D scene is displayed. In this editor, you can perform a variety of tasks that interact with your 3D scene and its objects. However, it's important to note that there are two helpful quick menus in the viewport. Simply press T as in Tools, or left-click this arrow here to expand the Quick Tools menu for the viewport. This includes tools such as the Select Box, Move, Rotate, and Scale. For hotkey users, keep in mind you can also use Shift Space at any time to bring up the same tools menu but labeled and at your cursor location. This works similarly to a pie menu in that you have the option to hold the Shift Space hotkey, move your cursor to the tool you want, and release the hotkey to select a tool. You can also press N as in number or left-click the arrow on the right to open additional quick settings, which include your item's transformation data, tool-specific settings, and other viewport options. You'll notice here there is an option for the 3D cursor. This is a very powerful tool which you can see right here. This red and white circle acts as the spawning point for any new objects and can be used as a reference for pivoting, which we'll go over in another video. To place it around your scene, simply hold Shift and right-click. To recenter the cursor, simply press Shift S and select Cursor to World Origin from the pie menu, or adjust the location and rotation settings in the right-hand side quick menu. Now, this feels like a good time to explain what pie menus are for those who are unfamiliar. Pie menus are quick wheel menus that appear around your cursor after a hotkey is pressed. You have three options when navigating a pie menu. The first option is to right-click to cancel in case you changed your mind. The second option is to press and hold the hotkey to initiate the pie menu, drag your cursor to your desired choice, then let go of the hotkey to select, with no clicking necessary. Or the third option is to let go of the hotkey that initiated the pie menu before moving your cursor, then use your cursor to left-click select the option you like. After you get used to where each option is, this can greatly speed up your workflow while also making several options available with less keystrokes. Throughout this series, you will see pie menus quite often for various different contexts. Now below the viewport we have the timeline. This controls playback of your animation. You can zoom in and out with your scroll wheel, drag the timeline with your middle mouse button, change the start and end frames for your output, and create and manipulate keyframes, all of which we'll go over in another video. The Properties editor contains several tabs vertically to display the properties of your scene, your current tool, and whatever object you have selected. To start at the top, this first tab represents the options your currently selected tool in the viewport may have. In this case, the Select Box tool gives you a few different selection options. The next few tabs, which you can see are separated by a small gap, contain your scene-specific properties. Just to clarify, your scene refers to your entire 3D scene. However, you can create more than one scene in a single Blender file by clicking up here. You can also select a scene from existing scenes using this drop-down. This back-facing camera icon is your Render tab. This allows you to change render engines, sampling, engine-specific properties, and other properties that affect your final image and how it's interpreted from the 3D scene. The next icon looks like a printer, and this is your Output tab. This is where all of your output settings can be tweaked before render: resolution, frame rate, file path, file type, and much more. The icon that looks like a stack of photos is the View Layer tab, and is similar to what used to be called render layers. View layers are typically used to separate background and character passes, for example, for easy compositing after a render. However, you'll notice this is only the pass properties, not the objects, and it's for only one view layer, the one we're currently in. To select a different view layer to change its properties, you'll need to go up here, similar to creating a new scene. You can create and select existing view layers here. While we're on the topic, I'd like to point out what this panel above Properties is for. In order to specify which collections of objects are rendered out in each view layer, you can check and uncheck collections here in what's called the outliner. I highly recommend using descriptive names for your collections and view layers by double-clicking them, but we will go over this in another video. Next, we have the General Scene tab. This has other miscellaneous scene properties that affect your scene, such as your active camera, your units, and rigid body settings. Finally, the Globe icon is the final tab of this section and is called the World tab. This includes properties for the sky and air of your scene. In other words, the surface option for your world is the shader used for your sky or background color, while Volume allows for volumetric lighting throughout the atmosphere of your scene as a whole, such as fog or mist. For the next section, the property tabs will be specific to the active object you have selected. So in this case, I will select the cube. Our first tab is the Object tab. This contains basic information such as location, rotation, and scale of the object. You can also specify parent-child relationships, which collections it belongs to, and visibility of the object. The next tab is a very important tab for Blender. Represented by a wrench icon, the Modifiers tab allows for powerful manipulation of objects using predefined modifiers. Simply select a modifier from the drop-down menu to add it to the stack below. You can use as many modifiers as you like and change the order or application of these modifications using these arrows. For example, the Subdivision Surface modifier and the Bevel modifier. This next tab is the Particles tab. You can see the icon looks like an object shooting particles out from its main body. In here, you can create particle systems and add them to the object you have selected. Next is the Physics tab, which looks like an orbiting planet icon. This contains several different types of physics simulations and physics manipulators, including cloth, rigid body, smoke, fluid, collision, and force fields such as wind. The next icon looks like two objects wrapped together. This represents the Constraints tab. This tab is very similar to the Modifiers tab, but deals more so with relationships of the objects you have selected with other objects or values rather than manipulating the object by itself. You can have an object copy the location of another object with the Copy Location constraint, stay above the ground with the Floor constraint, or point at another object with the Tracking constraints. The green triangle icon is for your object's mesh data. To explain what mesh data is, I can tell you that the reason why our cube is a cube is because of the mesh data. If I were to take this exact same object and change the mesh data, its shape would not be the same, but its object properties such as its location would remain the same. Here you can manipulate your vertex groups, also known as weight maps, your shape keys, also known as blend shapes, and your UV maps. Other geometry specific settings belong here as well. And finally, we have our Material tab. This is represented by a Material Sphere icon and is where you control much of how your object is shaded during render. The material you choose here will affect how shiny your object is. what color it is, and how rough it may appear to be. The final tab is actually in a different section, as you can see. There's a small gap there. This is the Texture tab, represented with a checkered canvas icon, and is not object specific. Textures exist as separate entities that can be referenced for a number of things, including the world, aka skybox, materials, or brushes. Because of this ubiquity, they are in a separate section. Before we move on, let's go ahead and left-click to select our lamp object. This is the dotted circular thing you see next to our cube. Once you have that selected, you'll have access to its lamp properties, which looks like a light bulb. This is where you can tweak its brightness, the radius of light, whether or not it casts shadows, and what type of lamp it is. We can also left-click to select our camera object, which is this sideways rectangular pyramid shape we have here. Now you should have access to the camera options, which include focal length, perspective type, and much more. And that's the summary for the default layout workspace we see when we open Blender. I hope this is helpful for you, and I'll be going into more detail about the other workspaces and what each editor does in separate videos. As promised, let's talk a little bit about how modeling works in Blender. The workspace itself can already tell us a lot on what modeling entails. As you can see, the object is in edit mode, which is very important for modeling since it relies on manipulating the vertices, edges, and faces of a mesh. You'll also notice that the modeling workspace opens the Quick Tools menu on the left for us already. While in edit mode, the left-hand side Quick Tools menu provides several more tools for us to use, including Extrude Region, Bevel, Knife, and Loop Cut, to name a few important ones. We'll go into more detail about some of these tools in their own videos. The modeling workspace also automatically brings us to the Modifiers tab of our Properties editor. Modifiers are very useful during modeling, and we'll be going over a few of those in their own videos as well. Additionally, there are several more options up here at the top of the viewport now that we're in edit mode. Each of these menus will give you additional operators to work with during modeling. That being said, most basic functions will be available through the Quick Tools menu alone. Just to demonstrate real quick, let's say we want to model a chair. You can do that very easily in the modeling workspace by simply selecting the appropriate tools. I'll be going over exactly how I made this chair as we learn more about the modeling tools. Object mode is the default mode of Blender and is helpful for manipulating objects as a whole. Objects can be moved around and animated throughout the scene. However, what this object looks like is determined by its mesh data. And mesh data can be edited through edit mode. Edit mode is the default mode of the modeling workspace, but you can also access it by simply changing this drop-down menu here in the top left-hand corner. For hotkey users, you can press Tab to toggle between edit and object mode. While in edit mode, you will be able to manipulate vertices, edges, and faces to change the shape of your mesh. Once finished, you'll be able to toggle back into object mode to move the object as a whole once again. It's helpful to know that your edit mode history and the action of toggling into edit mode all count as a step in your undo history. Therefore, after you finish an edit and go back into object mode, undoing your steps will correctly bring you back into edit mode with all of your edit mode history intact as well. For example, I'm just going to change this cube into a random shape by selecting one or multiple vertices and using the transformation tools to move, rotate, or scale the vertices around. Then we'll toggle back into object mode with Tab. Just to top things off, let's rotate our cube to add an action in object mode as well. Now let's say I changed my mind about something and want to go back in my undo history. Simply hit Ctrl Z to undo, and you'll see that our edit mode undo history is still intact and accessible. Fun fact, cameras, lights, light probes, empties, images, speakers, and force fields all do not have an edit mode. But there are non-mesh objects such as armatures, curves, and lattices that do have an edit mode accessible, but may look a little different. For these objects, you won't be manipulating mesh data, but rather the object-related data that they might have. However, the principles of editing these objects remains the same. Manipulate the building blocks to create what you need. Blender can also edit multiple mesh objects at once. To do this, simply select all the objects you would like to edit and go into edit mode. You'll notice that you'll be able to manipulate vertices, edges, and faces of any of the objects you have selected simultaneously. However, you won't be able to have any of the objects' mesh data interact with each other, as trying to connect vertices between objects will not work. For example, normally you can press F as in fill to join two vertices with an edge, But because these two vertices belong to separate objects, Blender restricts me from connecting them. In order to actually connect these vertices, I would have to join these two objects into one mesh. To do this, simply select them in object mode, go to the object menu, and select Join. For hotkey users, you can simply press Ctrl J. Once you've done this, you can now edit them in edit mode with no restrictions. In case you want to separate your mesh again into different objects, you can go into edit mode, select a part of your mesh, go to the mesh menu, and select Separate. Here you have a few options, but selection is the one you want. This will separate your selected geometry into a new object with its own mesh data. So how do we navigate Blender? This may seem intimidating at first, but it's actually pretty simple. Let's start with the 3D viewport. The first thing you'll be curious about is how to select things. Simply left-click any object to select it, and left-click empty space to deselect. You can also press A to select all, and Alt-A to deselect all. Some users may be interested in right-click select, which is arguably better for your health, so we made a separate video about that if you are curious. The next thing you'll want to learn is the basics of navigation, how to rotate, how to pan, and how to zoom your perspective of the viewport. To do that, all you need are these buttons right here. So let's say we want to rotate around our cube. Luckily, we have a very handy gizmo in the top right of our viewport that looks like this. Notice how it responds to our cursor floating above each axis. Go ahead and hover over the blue Z-axis indicator and left-click. You'll notice that it brings you directly into what's called top orthographic view. This can be done for any axis to snap to its corresponding perspective. However, if you instead click and drag the same gizmo, you'll find a much more flexible way of rotating your view of the world. It's important for some to know that you can also middle-click drag to achieve the same effect, but from any cursor position. Now, you'll notice that our view seems to pivot around a particular point in the viewport, that being the center or origin of our grid. This also happens to be where our cube is at the moment. However, what if we didn't want to look at the cube? What if we wanted to look over here or something? Well, now all you have to do is click this hand icon and drag to where you want to have centered. From there, you'll notice your pivot has changed when you rotate your perspective. For hotkey users, simply hold Shift and middle mouse drag to achieve the same effect, but from any cursor position. But let's say I want to focus back on my cube again. How do we do that? Well, for that, I want to quickly show you the Frame Selected tool, which can be found under View. This will reframe your perspective to focus on the object or objects you have selected. This can also be achieved by using the period key on a number pad. Now that we're this close to our cube, you may be asking, how do we zoom in and out? But it's pretty self-explanatory. We have a magnifying glass here. Click and drag it to zoom in and out, or you can use the scroll wheel or plus and minus keys on the numpad to accomplish the same task. And that's basically it for the basics of navigation, but you may have noticed that we haven't used the other two buttons in this area, the camera icon and the grid icon. The camera icon will bring you into the eyes of your camera. This is very helpful for setting up camera angles and previewing what will eventually be your output image. Alternatively, you can also use 0 on the number pad. The fourth button here is a grid. This may confuse you at first, but this switches your viewport between orthographic mode and perspective mode. I went ahead and set up a scene here to make it more obvious to you, but you may be asking, what's the difference between these two modes? Well, perspective mode is a realistic view of the 3D objects in your scene, which takes into account how far away objects are from you into how it displays the object. The further away something is, the smaller it gets visually. However, orthographic mode ignores all of that and flattens your world so that no perspective is seen. Everything is angle perfect. This is an unrealistic view but helps immensely with making models accurate, especially in relation to, say, a 2D concept sketch. But that's just the viewport. In the next video, I'll be talking about all the different windows we see here, what they do, and how to navigate them as well. Selecting objects in Blender is quite simple. We already went over it in the viewport navigation video, but to quickly review, left-click an object to select it, and left-click empty space to deselect. But there are other selection tools as well. You can press A, for example, to select all, and Alt-A to deselect all. However, what if I want to select multiple objects, but not all of them? Well, for that there is the Select Box tool. This is turned on by default, And with it selected from the Quick Tools menu, you can left-click drag to select multiple objects at once. To deselect multiple objects at once, simply Control-click drag in the same way. You can also enable the box select tool with the B hotkey, but in that mode you'll be using middle-click drag to deselect objects. An alternative to the select box is to press C for circle select, which acts more like a selection brush and only extends selection by default. You can, however, still use middle mouse drag to deselect while in circle select mode. Another way to select multiple objects is by simply holding Shift and left-clicking objects individually. To deselect using this method, simply Shift left-click the object again until it's no longer highlighted. You may notice that while you Shift left-click these objects, the most recently selected one is always highlighted in a slightly brighter orange outline. This denotes which object is the active object. The active object is the object whose properties will appear in the Properties editor. Now, just a quick tip. If you have objects or geometry obscured by other objects or geometry, it may be difficult to select them. To help with this, I recommend using wireframe mode, located here, to see through your objects. This makes things easier to select and also allows for selection tools like box and circle select to include otherwise obstructed objects or geometry. Now, it's important to know that each of these selection tools can be used for almost every context in Blender, including edit mode, pose mode, and many of the editors. However, in some editors you will be required to press B before entering box selection mode, such as the outliner. You may have also noticed a select menu in the top left of the viewport. If you open this menu, you'll notice several selection options laid out for you, as well as some viewport-specific selection options, such as Select All by Type, Select Active Camera, Select Linked, and more. Feel free to try these out yourself, but it's important to know that Select More/Less only works in edit mode, which we'll get into in a separate video. Now that we know how to select objects, let's start transforming them. Transformation refers to moving things, rotating things, or scaling things. So, let's say I want to push or pull my cube to a different location. This would be classified as moving the cube or translating the cube. I can open the Quick Tools menu and select the Move tool. You'll notice 3 colored arrows and 3 colored squares appearing on your selected object. This will allow me to click and drag any of the arrows to move the selected object along that axis. If you select any one of the 3 squares, it will move the object along 2 axes, excluding the axis of its corresponding color. For example, the blue square excludes the blue z-axis movement, but moves your object along the x and y axes simultaneously. But you can also left-click drag anywhere in the viewport to move the object along your viewing plane. Now, in case you change your mind about moving your object after you've already started dragging it, simply right-click before letting go of your left mouse button. This will work for all transformations. For hotkey users, you can press G as in grab to initiate the move along your viewing plane. You can then press X, Y, or Z to move it along a specific axis like the colored arrows did. Or you can hold Shift and press X, Y, or Z to move it along the other 2 axes like the colored squares did. You can right-click at any time to cancel the move, or left-click to apply the new location to your object. Fun fact, if you initiate any transformation with the mouse click instead of the hotkey, you can still use the X, Y, or Z hotkeys to perform similar axis-specific constraints on your transformation before you release your left mouse button. You can also switch your transformation entirely to a different one, such as rotation or scale, with their respective hotkeys. Please read the display at the bottom of your window while dragging your object around for more information. To reset the location of your object back to its origin point, simply press Alt-G. Now, what if we want to tip our cube over or roll it around? In order to do that, we need to rotate our cube. Let's check our quick menus for that. Aha! Yes, it seems we do have a rotate tool here as well. This will display a gizmo over the selected object or objects, showing each rotational axis. Just like the Move tool, you can left-click drag any of the colored rings to rotate along a single axis. But you'll notice there are 2 new areas, the outer white ring and the inner sphere inside of the colored rings, which you'll notice if you hover over it. The outer white ring can be used to rotate the object along your viewing vector. Imagine your eyes drilling a hole into the center of the object and spinning the object around that axis of rotation. The inner sphere is what you see when you hover over the space in between the colored rings. This can be left-click dragged to enter a free rotation mode, which opens all 3 axes to rotation, kind of like a trackball on a trackball mouse. This is my favorite mode of rotation as it's the most flexible. For hotkey users, simply press R as in rotate to initiate the rotation along your viewing vector. You can then, once again, press X, Y, or Z to rotate along the specific axis like the colored rings did. But you can also hit R again to initiate a free rotation like the inner sphere trackball did. And again, you can right-click at any time to cancel the rotation or left-click to apply the new rotation to your object. To reset your object's rotation at any time, simply press Alt-R. Now, let's say we want to make our cube much bigger or much smaller, which can be the difference between, say, a tissue box and a house. This would be known as scaling our cube. So let's go check our Quick Tools menu again, and yes, a scale tool. Selecting this scale tool displays a gizmo very similar to the move tool, except instead of colored arrows, it's like colored arrows with cubes of cheese stuck on the tips of them. Cheese. These work exactly the way you might expect. Simply left-click drag any of the colored axes to scale the object along that particular direction, big or small. You can also left-click drag the colored squares to exclude one axis from the scaling process. But what if you want to scale the entire object evenly? Just like moving, you simply left-click drag anywhere in the viewport. For hotkey users, press the S key as in scale to initiate the size change evenly for all axes. Press X, Y, or Z to scale along only a single axis, just like the colored arrows with cheese on them did, or press Shift X, Y, or Z to exclude an axis from the scaling, just like the colored squares did. You can right-click at any time to cancel the resizing, or left-click to apply the new size of your object. To reset the scale of your object back to its original scale, simply press Alt-S. Now, you may have noticed that during the rotation and scale procedures, there was a definitive center or pivot to the transformations. This is usually what the orange dot on your object signifies. However, what if you don't want to rotate or scale based on the object's pivot point? What if you want to rotate from the world origin or scale upwards relative to the floor level? That's where the 3D cursor comes in. This red and white circle is called the 3D cursor. It can act as the pivot point of any object as long as you click this drop-down menu here and select 3D cursor. Try it out with rotation and scale modes. You can move the 3D cursor throughout your scene by selecting the 3D cursor tool in the Quick Tool menu and left-click dragging anywhere in your scene or pressing Shift right-click. You can change the pivot point back to the default median point at any time with the same menu as before. The 3D cursor can also be used for moving your object. I personally love this feature for quick moving your object to a specific point. Simply move your 3D cursor to where you want your object to go. Then go to Object, Snap, Selection to Cursor. For hotkey users, you can simply press Shift right-click and then Shift S and use the pie menu to select Selection to Cursor. Just a friendly reminder, if you ever need to recenter your 3D cursor, Cursor to World Origin is also in the same Snap menu. Okay, now let's say I've run into the issue where I've rotated my object, but now I can't move the object along its own upwards axis. I'm stuck moving directly up, and that's not helpful. Don't worry, all you have to do is change this drop-down menu up here from global to local. This will change all gizmos to display the object's local axes instead of the global axes for all transformations. For hotkey users, you can access local axes simply by pressing X, Y, or Z twice instead of once after initiating your transformation. Another helpful tip for transforming your objects is to hold Shift when trying to be more accurate. Holding Shift while moving, rotating, or scaling your object will reduce the sensitivity of your cursor affecting the transformation values. In other words, it'll change slower as you move your cursor, giving you more nuanced control over the end result. In fact, holding Shift will achieve the same effect for cursor-dependent values in most other editors as well, for example, dragging a number along a slider. Alright, but what if I have a bunch of boxes that need to be perfectly aligned? Eyeballing it isn't very practical or helpful. This is where you can use the snapping options located at the top here. This magnet icon toggles snapping on and off, but you can also press Shift-Tab. The drop-down menu to the right of it allows you to snap to increments, vertices, faces, volumes, or edges. This way, you can align your boxes perfectly to each other without relying on guesswork. Selection and transformation are the foundation of manipulating your 3D scene in Blender. To add an object in Blender, it's really quite simple. Let's say we want to add another mesh. Maybe a torus, for example, or a donut. Simply go to the Add menu in the top left, go to Mesh, and select Torus. For hotkey users, you can simply press Shift-A to open your Add menu. You'll notice that the new mesh spawns where the 3D cursor is. This is an important feature of the 3D cursor. I'm sure you've noticed you can add things other than toruses. Inside the mesh menu alone, you can see all of these primitives here. Most of them are self-explanatory, but you might be curious about what this monkey option is. The monkey is the head of a character called Suzanne. Suzanne is Blender's alternative to more common test models such as the Utah Teapot and the Stanford Bunny. As a low polygon model of only 500 faces, Suzanne is often used as a quick and easy way to test material, animation, rigs, texture, and lighting setups. Fun fact, the largest Blender contest, which takes place at the Blender conference every year, gives out an award called the Suzanne Award. To delete an object, there are 3 ways to do it. Make sure you have the correct object or objects selected, then go to Object, Delete. For hotkey users, you can press X or the delete key. However, if you press X, you'll get a confirmation message. To confirm, simply left-click or press D. These delete functions also extend to almost every other editor where you can delete things. But it's important to know that the deletion menu in edit mode, for example, can look very different. Instead of a simple confirmation menu, deleting things in edit mode will bring up another menu, which will ask you for more information. For example, you can choose to delete the vertices, the edges, or the faces that you have selected, and each one will do something slightly different. If you delete vertices, it will also delete all connecting edges and faces of the vertices you selected. If you delete edges, it will also delete any faces formed by those edges, but it will not delete any vertices that also share another existing edge. And if you delete faces, it will also delete all edges and vertices within your selection, but not delete any edges or vertices along the boundary of your selection. Deleting only edges and faces will leave your vertices intact throughout your selection, even if they are floating in mid-air. Deleting only faces will leave you all of your edges intact throughout your selection, even if they're floating in mid-air. Dissolve vertices, edges, and faces are operators that try to combine the geometry in a way to act like your selection never existed. It will not always work, but can be very handy for removing loop cuts or extra subdivisions. Edge collapse will collapse all vertices along the boundary of your selection, caving in the geometry where your selection once was. Edge loops will functionally do the opposite of a mesh extrusion. It will reduce your selection geometry down to the next edge loop available. Edit mode has the most complex deletion options available, so while other modes and editors may have similar deletion options, they should be pretty self-explanatory if you can understand these. Modeling revolves around the editing of meshes. But what are meshes? A mesh is a collection of vertices, edges, and faces that describe the shape of a 3D object. But then you ask, what are vertices, edges, and faces? Vertices is the plural form of vertex, which represents a single point. Edges are the line segments between vertices. And faces are flat surfaces enclosed by edges, but some software will also call these polygons. You've probably heard the term polygons or polys when people refer to 3D models. If a model is made of polygons, it is a mesh. These are the building blocks of all meshes, and modeling involves the manipulation of these building blocks to create a 3D mesh. So how do we create meshes? Well, we already have our cube here, which is a mesh, but let's try to add another mesh. If we go into the Add menu we had used before to add objects, you'll notice that it looks a little bit different. Because we're in edit mode, Blender only allows us to add mesh shapes. These are the same options that belong to the mesh category in the Object Add menu. Let's go ahead and add a UV sphere. Right now, it's a bit hidden within our cube, so I'm just going to go ahead and hit G to move it outside. As you can see, this UV sphere is made of vertices, edges, and faces, and so it is a mesh. It should be noted, however, that adding meshes in this way will add the mesh shape to the original cube object's mesh data. If you toggle back to object mode, you'll notice that both the sphere and the cube are considered as a single object. If you want to add a separate sphere object, you're going to want to use the Object Add menu instead. You can do this by going into Object Mode in the top left. Then go to the Add menu, go to Mesh, and select UV Sphere from there. We will go into the differences between Object and Edit mode in a separate video. Now that you're able to create meshes, it's time to learn how to start editing them. The Extrude tool is one of the fundamental tools for modeling. But what is the Extrude tool? Well, allow me to simply show you. If you select a face and click the Extrude tool in the Quick Tools menu, you'll see this yellow gizmo. This is a normal axis manipulator. But what does that mean? Well, it certainly doesn't look normal, and that's because normals are a type of vector related to faces. Simply put, the normal is the vector that sticks out perpendicular to the surface of a face. If we go ahead and left-click drag this manipulator, you'll notice that it duplicates the face and moves it along the normal axis. But it also creates new edges and faces between the original face you had selected and the new duplicate face to maintain a connection. This is extruding. You can also left-click drag anywhere else in the viewport instead to move the extrusion along your viewing plane. You can do this for all types of selections, including multiple faces, vertices, and edges. However, if you select multiple faces that point in different directions, you'll notice that your manipulator is pointing at sort of an average value of where all your selected faces are facing. Keep this in mind as we'll come back to it later. It's important to note that if you right-click while dragging the manipulator, you can cancel the extrude, but it will not remove the duplicate faces. This is intentional, as it allows you to create new geometry at the same location as the originally selected geometry. This can be very helpful when wanting to scale or rotate your extruded mesh. For example, what if we wanted to create a stack of connected cubes? You could simply extrude, right-click cancel, and press S to scale your extrusion down. This will then let you extrude again and confirm to create the new smaller box. This was made super easy by the fact that the extrusion cancel brings the extruded geometry down back to the original cube surface. However, if you do this on accident and you want to remove the extrusion, just make sure you press Ctrl Z to undo it properly. For hotkey users, simply press E as in extrude to begin moving the extruded selection along its normal vector. Right-click will do the same thing I mentioned before, and left-click will confirm your extrusion. But the Extrude tool has a few more tricks up its sleeve. If you click and drag the Extrude tool icon in the Quick Tools menu, it will open up a sub-menu with more extrude options. The first option is our default option, so we'll skip that. But our next option is called Extrude Along Normals. This is what you might prefer to use if you select multiple faces that point in different directions. This will allow you to sort of push the geometry outwards along each individual face's normals, but still keep the faces connected to each other after extrusion. This is great for adding a layer of thickness to your mesh, for example. The next Extrude subtool is the Extrude Individual tool. This is extremely helpful for making certain faces extend out independently from its neighbors. For example, you could use this to create spikes or stylized bumps on a surface. Quick tip, this tool works best when faces are selected, not floating vertices or edges. The final Extrude tool is very powerful and easy to use. It's called the Extrude to Cursor tool and allows you to extrude your selection and extend it to the location of wherever you left-click in the viewport. This will still be along your viewing plane, but allows you to work very roughly and quickly when you need to. For hotkey users, if you're in edit mode, you can actually access the Extrude to Cursor tool at any time by simply holding Ctrl and right-clicking. Now that we've learned about the Extrude tool, I'm going to go ahead and show you how to make that chair I made earlier. This is what we want to make, and here's how we do it with the Extrude tool. Simply select your cube, go into Edit mode, and scale the cube down along the Z-axis. We will then use the Loop Cut tool, which will be covered in its own video, to make some additional cuts on our cube. To use the Loop Cut tool, simply select it on the Quick Tools menu and left-click drag to create a tic-tac-toe pattern, like so. This will then allow us to use our Extrude tool. Using Face Select mode, select the faces you would want to use to form the back of the chair as well as the legs of the chair. You can then go to the Extrude tool and select the subtool Extrude Along Normals. Then simply left-click drag to bring out both the chair back and the chair legs at the same time. Ta-da! You've officially modeled something in Blender. Let's talk about how to manipulate the vertices, edges, and faces of our mesh while in edit mode. By default, we can already select a vertex with left-click and move it around with the Move tool. We can also select multiple vertices with Shift left-click. This allows us to rotate and scale our vertices with their respective tools as well. You'll notice that when you select a bunch of vertices, there are edges and faces that exist between these vertices that you selected that will also get highlighted. For example, if you select two vertices, the edge between them will be considered selected. And if you select all four corners of our cube, you'll see that the face within these vertices is also considered selected. You can technically manipulate faces and edges simply by selecting the vertices that form them, but you can also change your selection mode. In the top left-hand corner of the viewport, you will see three icons that represent what selection mode you're in. By default, we're already in Vertex Select, but you can also change it to Edge Select or Face Select mode. These will allow you to select the edges or faces directly. For a more intuitive experience, you may enjoy holding Shift and left-clicking these icons to activate more than one selection mode at a time. For example, if we were to turn on every one of these modes at once, you could click anywhere on the mesh to select either a face, an edge, or a vertex at any time. Box Select, Circle Select, Shift Select, and most basic selection tools are available in edit mode as well. For hotkey users, simply use the 1, 2, and 3 keys on your number row to change your mesh selection mode. You can also hold Shift and then press 1, 2, or 3 to activate multiple selection modes. Another very important tool while in edit mode is Loop Selection. Depending on your mesh selection mode, you can select a loop of edges or faces by holding Alt and left-clicking. In Vertex and Edge Select mode, you will select edges when Alt-clicking, and in Face Select mode, you will select faces. Quick tip, in Vertex and Edge Select mode, the edge loop that gets selected is the one that runs along the edge you Alt-click. However, when in Face Select mode, the face loop that gets selected runs perpendicular to the edge you Alt-left-click. One very powerful modeling tool in Blender is the Loop Cut and Slide tool. To use it, simply go to the Quick Tools menu on the left while in edit mode and select it. Then, hover over your mesh with your cursor and you'll notice a yellow indicator that seems to loop around your mesh in various ways. If you left click, you'll notice that the Loop Cut has created a new loop of edges around your mesh where the indicator was, inserting new vertices wherever necessary. This is very handy for manually increasing the number of polygons in certain parts of your mesh for modeling. So that's the Loop Cut part of the tool, but what about the Slide part of the tool? Well, for that, all you have to do is left-click drag instead. You'll notice that instead of immediately creating the loop cut in the middle, it allows you to slide the loop along your mesh before letting go of left-click. The placement of your loop cut will then correspond to wherever you dragged it along the mesh. If you happen to start dragging the loop cut on accident and would prefer to cut your mesh along the middle after all, simply right-click before letting go of left-click to cancel the slide. If you notice in the bottom left-hand corner, after you've created a loop cut, an operator panel will appear that you can expand. This panel will include settings that will affect what your recently performed loop cut will do. For example, you can increase or decrease the number of cuts along your mesh, smooth your mesh based on a falloff, or slide to adjust your loop cut along your mesh with the factor value. For hotkey users, simply press Ctrl R. However, I should mention that if you already have the loop cut tool selected, Ctrl R will simply act as a left-click action, entering the tool into slide mode. So I recommend using the hotkey without the tool selected. Now, there are a few key differences between hotkey users and toolbar users for this particular tool. Assuming you do not have the loop cut tool selected and you press Ctrl R, you will also be able to very easily change the number of cuts you make by using the scroll wheel. This bypasses the need to open the operator panel to change the number of cuts. When left-clicking with the Ctrl R hotkey, you'll also notice that it automatically enters slide mode instead of creating a loop cut immediately like the toolbar tool does. Simply right-click to default the loop cut back to the middle of the section you cut, or left-click to confirm your slide position. Real quick, let's take a look at the practical application of the loop cut tool. For this, we're going to go ahead and make a chair. First thing I'll do is take my cube and scale it down so it's flatter. Then I can take the loop cut tool and cut my mesh in a few places that will give me more faces in particular areas of the mesh that I want to work with. For example, we're going to have to add the back of the chair as well as the legs of the chair. So let's make sure we have 4 faces we can choose from for the legs, as well as a row of faces for the back. From here, I can use the extrude tool, which will be covered in its own video, to add geometry to my mesh along my selection. I hope this demonstrates how useful the loop cut tool can be for modeling. Workspaces are customizable groups of panels or editors that can be used for specific workflows. Blender comes with predefined workspaces that can be found in the tabs at the top. These are labeled as Layout, Modeling, Sculpting, UV Editing, Texture Paint, Shading, Animation, Rendering, Compositing, Scripting, and an option to add your own. If you can't see all of the tabs, just know that you can use scroll wheel or middle click drag to show more. Simply left click any of these tabs to switch to them, and you'll notice they look different. The modeling workspace is used for creating models by manipulating vertices directly. This is why you'll notice that the vertices or corners of your mesh are now selectable. That's because the modeling workspace automatically brings you into edit mode instead of object mode, as you can see in the top left-hand corner of the viewport. You can change into edit mode in any workspace viewport by changing the value of this drop-down menu or pressing the tab key. But the modeling workspace tries to make itself as convenient as possible for you to get started modeling. It also removes the timeline, as modeling typically does not require any animation. The sculpting workspace is similar to the modeling workspace, but is used for creating models by manipulating meshes with a brush. Sculpting is a more freeform method of creating models and typically results in higher poly counts not usable for animation. However, it is a great way to start your creation process to then re-optimize your mesh later on. This workspace automatically puts you into sculpt mode, which is also accessible through the same drop-down menu in the top left-hand corner. However, there is no hotkey for this mode. The UV editing workspace is used for editing your UV projection maps, which is another way of saying, I skinned this object and stretched its skin across a flat surface. Anyway, this is a very handy tool for texturing your objects, as textures must be represented in 2D but projected onto a 3D object. You can see the 3D viewport on the right with an object's corresponding UV map on the left. If there was an image linked to this UV map, that image may become visible on the 3D object on the right-hand side, which would show you visually how the 2D texture has been projected. Texture paint is probably what some of you were thinking when I mentioned the complexity of UVs. Why paint on a 2D surface and project that to a 3D surface when you can simply paint on the 3D surface directly, like painting an Easter egg? Well, in this case, you can paint any object like an Easter egg. With texture painting, you can paint directly onto the 3D object, and Blender will project your painted texture onto a 2D surface based on the UVs. The shading workspace is a very important workspace used for manipulating materials, particularly with node-based shaders. The workspace puts your viewport into look dev mode, showing you in real time what your shaders would approximately look like at render. You can also access this from any viewport window using these buttons here. For hotkey users, simply press Z and use the pie menu that appears. If you want a more accurate display of your shader, you can also change it to rendered mode. If you play around with the numbers in the node editor below, you'll be able to see some changes in real time in the viewport above. It also includes an image editor and file explorer for any necessary image files. The animation workspace is catered specifically for animators to have all the tools they might need. The 3D viewport is where most of the animation will happen, but the dope sheet, which looks similar to the timeline, will be where all of your keyframe manipulation happens. You may also notice that there is a sliver of the timeline editor below the dope sheet. That is simply to provide all of the playback options, start and end frames, and keyframe navigation buttons the dope sheet does not have. For example, you can click this circle/record icon to start automatically recording changes in your object's location, rotation, or scale as keyframes for animation. The camera view on the left is also a 3D viewport panel, but focused on the camera's perspective. This is great for getting an idea of what the animation will look like at render. Now, there may be some of you who are wondering where the graph editor is. If you want to use the graph editor, simply create a new panel and select graph editor from the editor options in the dropdown. However, the dope sheet is so powerful with keyframe manipulation compared to other 3D animation software that the graph editor is not used nearly as often, but it can still be useful. The rendering workspace is used for testing or finalizing the output of your file. If you had a recent render, it'd likely be displayed here. It's important to note that this is the same image editor that we see in other workspaces. However, the image selected is render result, giving you access to slots, which serve as great temporary render test comparisons. These slots are accessible both through the top right drop-down, as well as the right-hand side quick menu, pulled up with the N hotkey, under Image. For hotkey users, you can use J to toggle between the most recent two slots, or use any of the numbers on the number row to go to a specific slot corresponding to that number. The compositing workspace is used for post-processing and After Effects that would add beautification to your renders, such as glow, blur, masks, etc. The compositor in Blender is node-based and is very similar to the shader editor in the shading workspace, but has its own editor in the drop-down menu. In order to start using the compositor, simply check Use Nodes at the top here. This will automatically generate a View Layer node and a Composite node. The Composite node is simply the end result receiver, your final output, and the View Layer node represents how you can use view layers to combine different passes, such as character and background in this compositor. Now you may notice that there is a dope sheet provided at the bottom, which is Blender's keyframe manipulator for animation. So why is it here? Well, let's say you're doing an animation where you want one particular part of the animation to have heavy directional blur because the camera is moving fast, but you want to turn it off after a certain point. In this case, you'll want to keyframe your blur property. The dope sheet is provided to help you keep track of those compositor-specific frames. The scripting workspace is for those instances where we might have to write some code. The text editor is very flexible. It can load and save files externally, enable syntax highlighting, enable word wrap, enable word lines, and a number of other useful coding tools. It can also provide easy-to-set-up templates for common Blender script functions, such as UI elements or gizmos. You'll notice there's also a console panel provided on the left. This is for seeing error messages at runtime. And at the bottom, we have what's called the info panel. This is a list of recent operations that have been performed by Blender, which usually correspond to actions the user has taken somewhere in the software. For example, if you select an object in the 3D viewport and transform it, you'll notice a new line appear in the info panel. You can copy and paste these operations onto your text editor for reference on how to use certain functions. And finally, we have our Create New Workspace option. This will bring up a few options, but you'll notice many of them are grayed out. This is simply because they already exist in your tabs. However, you can select Duplicate Current, which is a great way to start customizing your own. Simply duplicate the workspace and double-click the tab to rename it to whatever you like. If you'd like to bring a certain workspace to the beginning of the list for easy access, you can right-click the tab and choose Reorder to Front. You can also remove workspaces from the list by right-clicking and selecting Delete. Keep in mind that if you delete a custom workspace, it will be lost forever. In order to save a custom workspace, I recommend setting up a custom startup file by opening up a new file, setting up your workspace, and then going to File, Defaults, Save Startup File. Your workspace will then be included in every new Blender file you create. However, while you are looking through the new workspace options, You may have noticed that there are a few workspaces in the creation options that we haven't seen yet. We may go over these in another video, but I highly recommend looking into the strengths of Blender's 2D animation capabilities, as well as its powerful VFX and motion tracking capabilities. And that's the general summary of how workspaces work. We'll be going over specific workspaces in more detail in their separate videos. In this video, we're going to explain collections in Blender. To do that, we're going to try and separate our scene into two groups, one for characters and one for background objects. Collections are similar to what you might call layers or groups in other software. Each collection in your scene can hold objects of any kind for the purposes of organization and/or rendering. You can also have collections within collections for further organization. In fact, that's what's already being done, as the scene collection acts as the parent collection for all collections in a scene, as you can see here. Now, to start us off, let's make a scene that makes sense for our purposes. What we want to do is separate our scene into character objects and background objects. I'm going to go ahead and scale this cube up until we're inside of it. This will be our environment or background. Then I'm going to add a new object, monkey. This monkey, also known as Suzanne, will act as our character. If you take a look at the outliner, you can see that our monkey has already been added to our existing collection. Whenever you add objects in the 3D viewport, keep in mind that they will be added to whatever collection you have selected at the time. In case you can't see any objects in your outliner, your collection may be collapsed down to a single line. This is done by clicking this arrow on the left of the collection name. Simply click this arrow again to expand it. For hotkey users, you can press the plus and minus keys on the number pad. So let's try and move our character into a character collection. Well, for that, there are a few ways to do it. But one of the quickest ways is to simply select the object and right-click for a context menu. Under this menu, you'll see the Move to Collection option. If you click that, you'll be presented with a few choices. If we choose Scene Collection, this will bring our monkey out of its current collection. This is not what we want, and the only existing collection we see in this list is the one the monkey is already in. What we want is the New Collection option. So let's go ahead and click that and name our new collection Character. Quick tip, to confirm the name after typing, simply hit Enter twice. Now, if you look at our outliner, you can see that our monkey is in our character collection. For hotkey users, you can press M, as in Move, to bring the same Move to Collection menu for whatever object or objects you have selected. Another way you can add an object to a new collection is to create an empty collection first. To do this, simply right-click any empty space in the outliner and click New. This will create a new collection within the Scene collection. If, instead of empty space, you right-click a collection name, it will create a new collection within the collection you right-clicked. For hotkey users, you can simply hover over the outliner and press C to create a new collection in the Scene collection. And if you happen to have a collection already selected, your new collection will appear under the selected collection. Fun fact, you can create as many collections as you like. You can rename collections at any time by double-clicking or control-clicking their names in the outliner. So let's go ahead and rename our new collection as BG, or Background. We can then move our cube, which is our background object, to our background collection in the viewport with the same Move to Collection menu, or the M hotkey, and then selecting the now existing background collection from the menu. Or we can use the outliner and simply left-click drag the object to the background collection. Now that we have our character object and background object in their respective collections, you can check and uncheck each collection to toggle their visibility. This will turn them off during render as well for the view layer you have selected. To quickly show you how view layers work with collections, I will create a new view layer up here. As you can see, the checked or unchecked state of each collection is unique to each view layer. But what about our light and camera objects? Let's say we want to have these objects in both the background and character collections so that they are visible whenever we isolate either one. However, when we try to move our objects to more than one collection, it doesn't work. While it is possible to link objects to more than one collection using the Shift-M hotkey, a preferable way is to use collections within collections. Let's take a look at how that might work. First thing I'm going to do is rename our collection to car/bg, car being short for character. If we were to simply drag the character and BG collections into our car/bg collection, we can now toggle all collections within our car/bg collection off or on with one checkmark, but also keep the light and camera objects on while toggling the other two. Functionally, this achieves the same thing as adding the light and camera objects to both character and background collections, as you can keep the main collection enabled while toggling off the sub-collections you don't want to include. If you do happen to use Shift-M to link objects to multiple collections, however, it becomes a bit harder to keep track of, as there will be duplicates in your outliner even though they represent the same object. However, if you do link an object to multiple collections like this, just know that you can remove the object from a collection by right-clicking it in the outliner and selecting Unlink. Now that we have all of our objects in their proper collections, I want to explain a quick tip for when collapsing and expanding your collections. In case your outliner ever gets too busy, collapsing your collections can be very helpful. What's especially great is you'll notice a few icons next to the collection names. These icons represent what type of objects exist within each collection. For example, right now our character collection has only one object, but if you collapse the car/bg collection, you'll see that it contains two collections, two meshes, one light, and one camera. This is very helpful for seeing at a glance what objects are within each collection in case you need a reminder. Now, let's say for whatever reason, I want to delete this car/bg collection. Deleting a collection does not delete the objects within the collection. For example, if we select the car/bg collection in our outliner and hit the delete key, the collection is deleted, but the objects within the collection are moved outside of that collection. As a final tip, in the outliner, you can press the eyeball icon to toggle on and off viewport visibility. This will not affect your renders, but will allow you to hide objects and collections while you work. For similar options, you can click this drop-down menu in the top right-hand corner to enable selectability toggles and more. And that's it for our collection overview. Collections are very powerful and the foundation of object organization in Blender. UV mapping and unwrapping is the process of skinning your 3D object onto a 2D surface for texturing. If you want your image textures to properly project onto your mesh, this process is very important. But what does a UV map actually look like? What does it do? Well, let's go ahead and show you. Simply select your object and go into edit mode. Select your entire mesh by pressing A. Then go to your image editor and change it to the UV editor in the top left-hand corner. This is basically the same thing as your image editor, but will display your selection's current UV map over any image you choose for reference. It's also got a few extra settings specifically for UV editing. Alternatively, you can also go to the UV editing workspace, which will bring you to the UV editor automatically. As you can see, our default cube already comes unwrapped, as do most of our primitive meshes. This is the UV map of our cube. So instead of explaining it to you, I'm going to demonstrate how UV mapping works with an image texture. All I'm going to do is navigate to a file in my file browser and drag it to my shader editor as an image texture node. You can see that our UV editor automatically displays the image from our image texture node we have selected in the shader editor. But then, why is our cube still white? Well, to actually apply this image to our shader, simply click and drag the color output into the base color input of our shader node. If your texture isn't showing up, make sure you're in Look Dev or Rendered mode in the viewport. To understand UVs, let's go into the UV editor and select some faces. You can choose a selection mode in the UV editor just like you can in edit mode in the viewport. This will allow you to edit the UVs like you would a mesh. G, S, and R hotkeys also work the same as usual. However, we also have some extra tools in the toolbar. To transform without hotkeys, simply select the Transform tool. As you drag things around in the UV editor, you'll notice our image is distorting a little bit on the cube. For example, we can see that this square here is correlated with this square on the cube if we simply move it around a bit. We can also scale everything up to repeat the texture across the mesh. It's important to note that by default, the UV editor will only show the vertices, edges, and faces you have selected in the 3D viewport. This also helps make it clear which face in the 3D viewport correlates to which face in the UV editor. For example, we can go into face select mode in the viewport and select the face. That will isolate the corresponding UV face in the UV editor. However, you can also flip this function and have the UV editor drive what face you have selected in the viewport. To do that, simply click this opposing arrows icon on the very top left of the UV editor. Keep in mind, if you don't see all the buttons here, you can expand the UV editor or scroll along the top bar. With this mode toggled, we can now go into face select mode in the UV editor and select faces in our UV map, which will then select only the corresponding face in the viewport. Which function you want to use is up to you. I typically work with the default function as it keeps my UV editor clean. Now that we understand the UV editor and have an image projected onto our cube, let's go and take a look at the different unwrapping algorithms we can use. Unwrapping refers to the process of taking a 3D mesh, unraveling its faces, and laying them out on a 2D surface. To begin unwrapping, simply go up here to the UV menu, or press U. Even though our cube is already unwrapped, these are different unwrap algorithms that we can use. Unwrap is your standard unwrap algorithm. This simply takes into account what seams you have marked, which we'll get into in a little bit, and unwraps your mesh accordingly. Smart UV Project is one of my favorites and is great for unwrapping things quickly and roughly. Light Map and Follow Active Quads are similar, but have their own algorithms. Cube, Cylinder, and Sphere Projection are algorithms most fitted for objects similar in shape to the name of the algorithm. Project from View is a very powerful tool that essentially takes what you see in the viewport and flattens it as your UV map. This is a very basic way of unwrapping your mesh and will not hold up from different perspectives, but can be used selectively to great effect. Project from View Bounds simply stretches the resulting UV across the UV editor. I'm going to demonstrate this one real quick, so let's go ahead and select Project from View. As you can see, the image projects pretty well on our cube from this perspective. However, if we rotate our perspective, you can see that the image is now stretched across the sides that are perpendicular to our view from before. That's because, as you can see in our UV editor, there are not enough pixels for those faces in the UV map. Now, you may have noticed that we can't get the original mapping of our cube back. Pressing the unwrap option doesn't seem to do anything because our cube is already unwrapped. So let's go over exactly how to use the basic unwrap function. To do this, we need to mark some seams. Seams are the edge loops where you specify for Blender to cut open your mesh when skinning it. Simply select the edge loops you wish to mark or clear before clicking each option. So let's go into Edge Select mode and select these three edges. I'm going to do the same thing on the other side of the cube. Then I can click Mark Seam in our Unwrap menu to mark these edges as where we want to cut open the mesh. This will make them appear slightly redder. Then I'm going to go ahead and select this edge as well and do the same thing. Now I can select all of my mesh and go to the Unwrap menu and select Unwrap. As you can see, we have something more similar to what we had before. In case you don't understand why I chose the seams that I chose, let me walk you through my thought process. The arms of the cross we see in the UV map are these faces here. They needed to completely detach except for one connected edge, so I marked seams on the three other edges of each of these faces. Then we simply needed to separate the head of the cross from the tail of the cross. That's what this seam was for. As you work with your own meshes, you'll get a feel for what seems to work best for you to get the UV map shape you want. Oftentimes, the most important thing to get right about your render output is your output file itself. The settings for this can be found in the Output category in your Output Properties tab. This is the tab labeled with a printer icon. Here you can immediately see a line where you specify your file output path. Simply click on the folder icon to open the file browser for easy navigation, or left-click the path and type it manually. You will want to make sure to include a file name at the end of this path, but don't include the extension, as that will be provided for you as a checkbox below. Very quickly, I'll go over these checkboxes. Overwrite is a checkbox to specify that if a file name is identical, simply overwrite it without confirmation. This is on by default for a reason, because if you check this off and you start a render after already rendering your scene once, the files generated by the previous render will not be updated. Therefore, your new render will not be recorded. There are times where you would want this, but most of the time I recommend leaving this checked on. Placeholders is a great way to create the file name before the render finishes. By default, the file itself does not get generated until the render is done with that frame. Cache results will save your render cache, aka your slots, as an open EXR file, which can sometimes speed up compositing calculations in post-processing. This is relatively situational, and default settings for all 4 of these checkboxes are typically fine. Next, you have your file format. This should be familiar territory if you've ever worked with images or videos before. PNG is a great image file format to use, and your render will output each frame as a separate PNG file on your hard drive. Feel free to use any of the other file format options Blender has available. If you choose a movie file, you'll have an additional section called Encoding that has settings you should tweak. For starters, your actual file extension will be specified by the container value. Also, to make sure you include any existing audio in your render, make sure to select an audio codec from the drop-down menu. Quick and very important tip: even if you're rendering an animation, it is recommended to output image sequences instead of movie files. This is because in case your render fails midway, the files up to that point for your image sequence have already been output, so you can still pick up where your image sequence left off. However, if you are rendering a movie file format, a render that fails halfway will never even become a single file, as it will output a corrupted, incomplete file, leaving you to start over completely from frame 1. Color type lets you choose between black and white, RGB, or RGB plus alpha. RGBA allows your images to include transparency and is usually recommended, especially if you're rendering out passes. Color depth changes the amount of color information in your image. Compression simply affects the file size of your output. Now that we've gotten those settings out of the way, let's quickly show how this works. I'm going to go ahead and animate my cube really quick. I can then render it out by going to the render menu. Here we have 2 options, render image or render animation. If you were to select render animation, you would see the output files being automatically generated for you like so. For hotkey users, you can simply press Ctrl F12. Once your rendered animation is done, you can also view your rendered animation by going to the render menu and selecting View Animation. For hotkey users, you can simply press Ctrl F11. Now, if you were to select render image instead of render animation, Blender will not output a file for you automatically, as this would actually overwrite a lot of important frames when running single frame test renders. But let me show you how to save a single frame if you need it. Let's go back to the render menu and select render image. For hotkey users, you can simply press F12. From the new render window, which is simply an image editor popped out, you can go to the image menu at the top and select Save As. This will allow you to save the image as a new file using the output settings you specified in the Properties editor. If you don't see this new render window, simply go to the render menu and select View Render. For hotkey users, you can press F11. Rendering in Blender is the part where you finally get to pump out your animation or still image out of Blender and into a beautiful image or video. To see how this all works and what options you might have for this process, let's go into the Render Settings tab of the Properties editor. This is labeled with the backwards-facing camera icon. This tab can be a bit intimidating, so in this video we'll be introducing the important settings and going over some specific ones in the next few videos. But before we go over anything here, you'll want to learn how to render. To render a still image, go to the render menu in the top left and select Render Image. To render your entire playback range, simply go into the same render menu and select Render Animation. For hotkey users, you can press F12 to render an image and Ctrl F12 to render an animation. Now let's go back to our Render tab and do a quick overview of some of the settings that will affect these renders. The first setting is your render engine. This is a drop-down menu with 3 different engines, Eevee, Cycles, and Workbench. The differences in each engine are covered in the Introduction to Shading video, but I'll go over them once again. Eevee is your real-time render engine. This is currently Blender's default engine and is node-based, just like Cycles. In fact, Eevee and Cycles can share nodes between each other. This means you can often preview your shader in Eevee and render it in Cycles later. Why would you want to do this? Because Cycles is a more accurate, more realistic engine, but takes a lot longer to render. Workbench is Blender's preview render engine. It is technically the same engine that drives solid view in the viewport, and so you know generally how it looks, but Workbench as a separate render engine exists so that you can keep your render output settings for your preview animations the same, while still being able to work flexibly in the viewport. Depending on what engine you have selected, you will see different settings below. I'm going to quickly go over each one, but I do recommend experimenting with these settings when you can. Let's start with Eevee. Immediately you'll see a sampling setting, which allows you to set how many samples Eevee will take during render, both in viewport and at render time. The higher the samples, the more accurately the engine will calculate your shaders. Both Cycles and Workbench have this setting as well. Next, you'll see a few things that will directly affect a lot of the visual aspects of your render, namely ambient occlusion, bloom, depth of field, subsurface scattering, screen space reflections, motion blur, volumetric, hair, shadows, and indirect lighting. These are engine specific, and I recommend you play around with each one as their settings can go quite deep, but their names should make it self-explanatory what they will affect. To test them out, simply go into Rendered View in the viewport and adjust freely. Just so you know, for some of these features, such as motion blur, you'll have to enter the camera view. Film is a setting that is shared by all three render engines. One of the most used settings in this category is the transparent checkbox. This affects the sky. If you click transparent, Blender will automatically replace the sky with full transparency for your output image. Simplify is also a shared render setting between all three engines. It actually pertains more to the scene itself, but does have settings that can affect render. Basically what it does is disable subdivision modifiers past a specific value to reduce the overall poly count of your scene. This is typically used to help the viewport run more smoothly, but also has a value to specify max subdivisions at render. Freestyle is a powerful tool that allows you to do non-photorealistic outlines and strokes in your render based on a plethora of different settings. However, this checkbox is to simply enable it at render. The real freestyle settings are in the View Layer tab. Freestyle is also available in Cycles, but not in Workbench. And finally, we have Color Management, which is also available for all three render engines. This one is pretty self-explanatory. It manages color. Feel free to experiment with these settings as they will affect how your colors are interpreted for your output render. Now, if we switch over to the Cycles render engine, you'll see that the options we have are slightly different. The first thing you'll notice is the ability to switch between CPU and GPU. This is a very important setting for those wishing to take advantage of their graphics cards to decrease render times. If you don't have GPU as an option or it's grayed out after selecting GPU, you might need to go into your preferences, go to System and select CUDA. If your graphics card is not listed underneath here, it may not be supported. But if it is, make sure it's checked and then go back to your GPU-CPU dropdown and it should be working just fine. Sampling works the same as Eevee, but has a few extra settings you can play around with. Light Paths gives you options to change the accuracy of the light in exchange for render times. The volume and hair settings will affect the quality of volumetric shaders and hair particles respectively at render. You can see these in the rendered viewport for testing, but motion blur is not real time for Cycles. For that to be visible, you'll have to render an image by pressing F12. Performance is an important setting for Cycles, especially if you're switching between GPU and CPU rendering. Tiles are what Blender divides your image into. During render, Blender will complete the render of a tile or chunk first before moving on to the next one. The most efficient way to divide up your render depends on each shot, but the general rule of thumb for CPUs is to keep the tile relatively small, as CPUs can render multiple tiles simultaneously. Default settings usually work great for CPU rendering. However, for GPU rendering, the general rule of thumb is to keep the tile large, as it only renders one tile at a time. so you'll want to adjust the tile size accordingly. For GPU rendering, I typically recommend a tile size of 256 by 256. There are also a few other settings you can play around with. And finally, the bake category includes the bake button. This button is used to bake lighting into textures so you can use them instead of recalculating the lights every time. Now let's go over the workbench settings. But if you're already familiar with the viewport solid view settings, you'll find these to be very similar. Workbench also has sampling, but generally it does not have to be very high, especially since Workbench is mostly for preview renders. As usual, if you want to see how each of these settings affects your render, simply go into rendered mode in the viewport and tweak them as you like. The Workbench specific settings here are lighting, color, and additional options. Lighting allows you to change how your scene is being lit. Studio is your default, and you can choose different presets by clicking on this sphere. You can also click the globe icon to rotate the light source direction. Matte cap is another great way to see your scene very clearly, especially during sculpting or modeling. More matte cap presets can be found by clicking on the sphere. Flat is just giving all your objects a single color with no lighting. The color settings allow you to change the color of the objects in your scene based on different parameters. My favorite option is the random option, as it gives every object a random color and makes everything super easy to see. Under options, you'll have miscellaneous stylized options that affect your scene visually, such as X-ray, shadows, depth of field, and outline. That's it for the render tab settings. However, there's also much to be learned about the related output settings tab right below it. This is labeled with the printer icon tab. Here is where you'll be able to change information regarding your render output file, such as resolution, file path, file format, and metadata. This tab is not render engine specific. Now that you've gotten a general idea of what these render settings are for, I'm going to go a little bit more into detail about some of these settings in the next few videos. Character rigs are definitely the most common type of rig. So in this video, we'll be going over how to rig this character mesh. You can download this base mesh in the description down below. So to start things off, if we want to create a humanoid skeleton for this character, we'll have to think about what bones we need to deform him. Let's see, we would need thighs, shins, feet, upper arms, forearms, heads, a head bone, several spine bones, maybe collarbones? This seems like a lot to keep track of if we're doing it from scratch. Luckily, Blender provides a basic humanoid skeleton for you already. Let's figure out how to access it. Normally, when you add an armature object from the Add menu, the only choice you have is the single bone that spawns when you click it. However, we can turn on a native add-on that lets us add an armature like usual, but gives us the option to have the armature come as a pre-made base human skeleton. To do this, all we have to do is go to Edit, Preferences, Add-ons. From here, we can go to the search bar and search Rigify. Rigify is one of Blender's auto-rigging systems, and can be very powerful, but we'll get into that later. For now, we want to simply turn on Rigify. Feel free to read up on the documentation of any add-on by clicking its respective documentation button here. Let's close out of our preferences window and try again to add an armature object. This time you'll notice that we have an additional menu when selecting armature. Feel free to try all of these out because they're pretty cool. However, for our purposes, since our character is a human, we're going to be using the human meta rig. Our next step is to simply match the joints with how we want the character mesh to bend. In other words, elbows should match with elbows, and hands should match with hands, etc. For this, we'll need to go into edit mode. Once in edit mode, we're going to want to first match the size of our character. Right now, it's a bit big, so let's scale it down a bit. But when we do that, it's a bit disappointing to have the rig move up off the ground when it was already at perfect floor level. So we can simply change our pivot from median to 3D cursor. Hotkey users can press the period key and select it from the pie menu. Now, when we scale, we can have the feet stay in place while the rig gets shorter. Just what we wanted. If this isn't working for you, make sure your 3D cursor is in your world origin. You can change that by hitting Shift S and selecting Cursor to World Origin in the pie menu. Let's just scale it down until our skeleton fits inside of our character. I typically use the collarbones as reference. We also have a bunch of facial bones that we won't really need for our basic character, so let's delete them. But which ones can we delete and which ones do we need? Truthfully, the only bone you'll need here is the head. So let's just select everything here with the box select tool, and then deselect the head bone, which is actually labeled spine.006. Then delete all the facial bones at once. From here, our arms are clearly not matching, so I'm going to select the bones and move them where they belong. But you might find this a bit tedious to do for the whole body. Luckily, however, we only need to do it for half the body. To mirror edits you make on the bones on one side of your character onto bones on the other side, simply open the right-hand side menu and go to Tool. Under here, you'll see Options, where you'll be able to enable X-axis mirror. Now, whenever you move a bone on the left side, the right side will follow. Let's continue matching our rig to our mesh. For this, it might be easier to turn your pivot point back from 3D cursor to median point. The most important thing about matching your rig to your mesh is that the elbows and other similar joints match. For the spine, we'll simply make sure that it follows the general location of where a real spine would be, and for the head, we just need to make sure the pivot point is good and it fills the whole head. The collarbones should also not be too long or too short, so adjust accordingly. Now, our character has no fingers except for the thumb, so we can go ahead and get rid of all the fingers except for the thumb, the index finger, and the pinky. Oh, and technically if your character is male, you can delete the breastbones if you like. Or you can leave them in if you plan to use them in some way. Up to you. But if you do, make sure those have proper placement as well. Now that we've done all of that, let's parent our character mesh to our rig. We can do this by going back into object mode, selecting our mesh, then shift selecting our armature. From here, we can right-click and go down to Parent. Hotkey users can still press Ctrl-P for the same menu. From this submenu, you'll notice a section labeled Armature Deform, under which we can select With Automatic Weights. From there, we can select our armature and go into Pose mode. This will allow us to test the rig and see if the mesh is following the bones as intended. Now, if you're like me and you forgot to parent the eyes to the armature as well, just select it, shift select the armature, and parent it in the same way. It looks pretty good. If there are any issues with the deformation, make sure to correct the weights by editing the vertex groups of the character mesh. You can learn more about how to do this in the separate vertex groups video. Now, some of you might be wondering why it's called a meta rig. This seems to imply that it's sort of an in-between step for something else. Well, while the Rigify add-on does provide these meta rigs for easy humanoid skeleton rigging, that's not all it does. In fact, its main purpose is to automatically generate all of the advanced rigging features an animator might need, including IK, FK, custom bone shapes, and more. So while we can use the meta rig as an actual rig just like we did earlier, if you wanted to use the meta rig for generating a new advanced rig instead, there's just one extra step we need to do. To go over the steps from the beginning again, simply add the human meta rig, or any Rigify meta rig actually, to your scene. Then adjust the joints in edit mode to match your character, making sure not to delete any vital bones. If you were to, the Rigify generation would not work. You might be asking, how do I know if it's a vital bone? Well, if you're unsure, just reference the basic human meta rig. Any bones in this rig, save for the breastbones, are typically essential for generating a Rigify rig. Now, instead of parenting your mesh to the armature, simply go into the Armature Data tab, denoted by this green stick figure icon, in the Properties editor. Here, if you scroll down, you should see a large Generate button. Click this and wait until it's done. And there we go! You have just generated an advanced Rigify rig with constraints, custom bone shapes, and other advanced tools all customized to fit your character's shape and size. From here, you can just select your character mesh and shift select your new Rigify armature and parent your mesh to your rig as you did before. This rig is quite powerful. However, if you want to learn how to set up inverse kinematics or bone layers yourself, we will address these in separate videos. I hope this video gives you a good understanding of how character rigging works in Blender.